And this is going to talk about some matrix groups that are going to come up a lot in the course. So the first one to know about is SL2Z. This is short for the special linear group. And these are 2 by 2 matrices with the properties that the entries are integers and the determinant is 1. And then subgroups of SL2Z that we're going to talk about a lot are subgroups called gamma not n. So this is gamma, and then not is this British word for 0. And this is defined to be the subgroup of SL2Z where this integer n that appears in the notation divides the bottom left entry of the matrix. And this n is called the level. And I don't know for sure, but I assume that this comes from the word niveau, which is a French word meaning literally level. So why people think about this group gamma naught n is kind of a long story and not super relevant for this course. One thing about the group SL2Z is that it acts on what's called the upper half plane. So I'm going to define the upper half plane denoted with this cursive H, and this is going to be the set of complex numbers that I'm going to write as x plus iy, where x and y are real numbers. And this has the upper half plane is the set of such complex numbers where y is strictly positive. So it's just, you can imagine visually the upper half plane, and it's clear why this is called this. And SL2Z has this property that it acts on the upper half plane, and the action is given by, if you have a matrix ABCD acting on this complex number Z, you define that to be AZ plus B over CZ plus D. This is called a Mobius transformation. And one thing you'll notice about this action is that minus the identity matrix acting on Z, by definition this is going to be minus 1 times Z plus 0 over 0 times Z minus 1, and this is again Z, right? So minus I acts as the identity on the upper half plane under this action of Mobius transformations. And that leads people to consider this quotient of SL2Z called PSL2Z. So P here stands for projective, so this is the projective linear group. And this is just defined to be SL2Z quotiented by the 2-element subgroup containing minus the identity. And as we just discussed, because minus I acts as the identity on the upper half plane under this action, PSL2Z also acts on the upper half plane. And the reason why I mention this is because I want to give a warning, which is that sometimes the subgroup gamma naught n is taken to be a subgroup of PSL2Z. And when people do this in the literature, it'll lead to certain factors of 2 appearing, because essentially you have half as many elements in some sense. So just be careful when you're working with these and when you're looking at gamma naught n, because the paper you're reading might, if you have some really technical formula and you need to get it exactly right, then it's good to know if the author is taking it, if the author is taking gamma naught n to be a subgroup of SL2Z or PSL2Z.